Fahad, can you send those doubts on my WhatsApp? I will reply you there. Okay, Fahad, send those doubts in the assignment. Okay. So those who did not attend the class, this is for them. You have just started. I just started recording. You can take a screenshot. You have just done one reaction here. Yep. Okay. Now, the second reaction that we are going to discuss today is a reaction with aryl sulfonyl chloride. This is the sixth reaction. Okay, this is important reaction. Please remember this reaction. This is also used as a test to distinguish between 1 degree, 2 degree, and 3 degree amines. First of all, what is this aryl sulfonyl chloride? We have this benzene ring, which is attached with sulfur with a double bond O, and this chlorine. This is also known as Hinsberg's reagent. Hinsberg's reagent. Okay, what is the use of this? Used for distinction of 1 degree, 2 degree, and 3 degree amines. Now, I will give you the tests. How is 1 degree distinguished from 2 degree and 3 degree? So if you have 1 degree amine plus the Hinsberg's reagent, then it is going to be soluble in alkali. Two degree amine plus the Hinsberg's reagent. This is going to be not soluble in alkali. It will give a product, but it will not be soluble in alkali. And 3 degree amine plus Hinsberg's reagent, it does not give any reaction, no reaction. Now, if I look at a primary amine, I will have this aryl sulfonyl chloride, this benzene ring with sulfur double bond O, and chlorine. And then you have nitrogen with alkyl group, and there are 2 hydrogens. Okay, so primary amine will always have 2 hydrogens. Okay, it will have 2 hydrogen and 1 alkyl group. Now, when I react this HCl, they react with each other, and what happens here? This nitrogen atom, basically, hota kya hai? This sulfur is going to be very delta positive because it is attached with 2 oxygen and 1 chlorine. All of them, 3 of them are what? Very highly electronegative element. And this nitrogen, it has a lone pair electron, so it attacks on the sulfur atom. Okay, it attacks on the sulfur atom. It first of all breaks the pi bond. Oxygen gets the positive charge. Then again, oxygen gives back the electron, and chlorine leaves as a leaving group. Okay, and from here, the hydrogen leaves as a leaving group from nitrogen atom. So basically, you get a bond between sulfur and nitrogen. You have double bond O, and then you have nitrogen, and this has lost 1 hydrogen. Okay? Nitrogen has lost 1 hydrogen. It has 1 hydrogen remaining, and the alkyl group is as it is. Now, the important part is that this hydrogen, it is quite acidic hydrogen. Why it is very acidic hydrogen? Because if I remove this hydrogen, nitrogen will get a negative charge. H plus will leave, hydrogen will leave as H plus, giving the nitrogen the negative charge, and this negative charge can be in resonance with the sulfur here. It can be resonance with this oxygen also. So it can be in resonance with the sulfur's oxygen, and furthermore, that resonance can also go through this benzene ring. So this hydrogen is quite acidic hydrogen, and that is why it is therefore soluble in alkali. This acidic hydrogen. Therefore, if I'm going to mix this with alkali, then it is going to do what? It is going to completely mix, and it will be soluble. Therefore, soluble in alkali. This product will be soluble in alkali. Now, if I look at the 2 degree amine, So I have nitrogen. There are two alkyl groups here, CH3, and then you have the ethyl group, and here we have a hydrogen atom. Now the reaction will still take place here, that this hydrogen and chlorine, they will get together. Chlorine will leave from the sulfur, and the hydrogen is going to get away, and you are going to get a product that is sulfur double bond O with nitrogen, the ethyl group and the CH3 group. Okay, but the problem is that there is no acidic hydrogen here, right? And that is why it is not soluble in alkali, right? No acidic hydrogen, therefore not soluble in alkali. Okay, and then if you look at 3-degree amine, that 3-degree amine will not have any hydrogen for the reaction to take place. That is why they do not react. Please write 3-degree amine does not react with Innsbruck reagent, as the nitrogen of amine does not have any hydrogen. Now, right, next, electrophilic aromatic substitution of aniline. Now, first of all, if I look at aniline, it will have a benzene ring that has a NH2 group. And this NH2 group, it will have a lone pair electron, which will be in conjugation with the pi electrons of the benzene ring. And that is why it will show resonance. And double bond NH2 with a positive charge on nitrogen, negative charge on the ortho position. And you know that the next resonating structure will be like this. The negative charge will form a bond here. This pi bond will convert itself to negative charge here. So you can make further resonating structures, but the resonance hybrid that you are going to get is going to have a high electron density at ortho and para position. Okay, so you have NH2. You'll have delta negative here, and delta negative here. Therefore, we can say that NH2 group is highly activating and ortho para directing. And it is ortho para directing. And it is so activating, and it increases the electron density at ortho and para position so high that if I do simple electrophilic aromatic substitution, for example, if I do bromination, in bromination, it does not give me ortho and para product. It gives me a tri-substituted product. So I get bromine in all of these three places where the electron density is high. We have the NH2 here. And in both of these ortho positions, I get bromine. And in the para position also, I get bromine. So we get a tri-substituted product. Okay. Now this gets a problem if I need a mono substituted product. That means I want bromine only at one place. Then for that, what I need to do, I need to get hold of this lone pair electron. This lone pair electron is the one that is activating the group and it is increasing the electron density at ortho and para position. Now, in order to deflect this particular lone pair electron, we add a acyl group here. So please see what we do. We have NH2 and we react this with acetic anhydride. So this carbon atom, this nitrogen atom here, it attacks on the carbonyl carbon. Okay. And then this group completely leaves away. Okay. This group completely leaves away and we get the benzene ring, the nitrogen atom attached to it. Okay. And nitrogen, it gets away with one of the hydrogen. This nitrogen atom has attacked on the carbonyl carbon. So it attacks on the carbonyl carbon like this, double bond O. And then we have the CH3. Okay. Now, if you look at this lone pair electron, just a second. Yeah. Now, if you look at this particular lone pair electron that is on nitrogen atom, this nitrogen atom's lone pair electron, it can have a resonance with the benzene ring, right? And it can also have a resonance with what? It can also have a resonance with this carbonyl carbon. Okay. So it is not completely available for the benzene ring. It is also available for this oxygen atom. So it is less available for the benzene ring, and that is why it becomes less activating. And also one more thing happens. We have, this is known as protecting the nitrogen, protecting this ortho groups here. This ortho positions, it cannot be attacked because here we have a high hindrance. That is why. And the other thing is that it is not highly activating. This particular nitrogen, it is also having resonance with carbonyl carbon. So it is less activating than the pure NH2 group. And that is why when I have a reaction with Br2, aqueous Br2, bromine water, I get only one product, a mono substituted product. This is as it is. C double bond CH3, and I get a bromine just in the para position. Okay. And to get rid of this acyl group, you can do acidic or basic hydrolysis. You just add water in the presence of H plus and OH negative, and you will get back the amine. The Br will be as it is, and you will get the NH2. Okay, so this is how we get the para substituted aniline. So it is important. Please write this down. Okay, this reaction is important. They can directly tell you how will you get a para substituted aniline from aniline. आप Br2 आपको सीधा नहीं लिख सकते. You have to first of all do the acylation in which you add the acyl group, then do the bromination. Okay, right now. NH2 group is highly activating and gives tri-substituted product on electrophilic aromatic substitution. To control this, acylation with acetic anhydride is done. Then the desired electrophilic substitution reaction is done. Right here. After acylation, the lone pair of nitrogen So it shows resonance with carbonyl group. Shows resonance with carbonyl group, and hence make the lone pair less available for benzene ring, decreasing its activating power. And then you will show it like this. You have the phenyl group, nitrogen with one hydrogen, C double bond O, CS3. This lone pair here, it is now having resonance with this two also. So pH, nitrogen and hydrogen are as it is, double bond carbon, single bond oxygen negative, CS3, and nitrogen will have a positive charge because it has 4 bonds. If you show this resonance also. Okay, so this answer after acylation is the, this is the answer for the question, why acylation is done. Okay. Why is the control needed? Why is acylation done? So you'll say that the NH2 is highly activating. And then if they ask you guys why acylation works, okay, then you will say that the lone pair electron is also in resonance with carbonyl group as well as the benzene ring, and hence making the lone pair less available for benzene ring. And that is why it decreases the activating power. And then what do we get? We get a mono substituted product rather than tri substituted product. The second reaction, nitration. Okay. Now in nitration, we have another problem. Please see. We use conc HNO3. And we use conc H2SO4. Rather than getting two products, that is ortho and para substituted, we get highest amount of para substituted product, that is 51%. But the next highest yield that we get is the meta substituted product, not ortho. This is somewhere around 47%. And then we get 2% of ortho product. Now, why this happens like this? Now, it is very important to look at the reagent. The reagent here is HNO3. Okay. And if you have HNO3, this HNO3 will have a lot of H plus ion, right? Because of this HNO3 and concentrated H2SO4, there will be a lot of H plus ion that will be surrounding the aniline. And in aniline, we have the lone pair electron. So this lone pair electron will attack on the H plus ion and making it NH positive. Okay, so it will become NH3 positive. You see. Now this NH3 positive, it is what? It is the electron withdrawing group. It is not electron donating group now because it has a positive charge. It becomes electron withdrawing group. And that is why we get a meta product here. Okay, that is why we get a meta product here. So please write. In presence of concentrated acid, the NH2 of aniline gets protonated and become NH3 positive, which is a deactivating, and meta-directing group. Hence, we get significant amount of meta product. Now, the same thing, in order to control this, what we are going to do, acylation. It's the same nitration, just in the presence of acylation. And this, we have the last reaction, that is sulfonation. Now, in sulfonation, we just use concentrated H2SO4. Acha, Abdurrahman, sorry. Let me know, Abdurrahman, once you're done. A bit more. अब आपने कुछ नहीं लिखा क्या? अरे पूरा लिखना बाकी है, आप साथ साथ लिखा कीजिए भाई. Let me know once you're done, Abdurrahman. Done. All right, sulfonation. Now, in sulfonation, we use concentrated H2SO4. Now, the first thing that happens here is this nitrogen, it gets the hydrogen from concentrated H2SO4. So it becomes NH3 and it will get a positive charge. Now, what remains in H2SO4 is HSO4 negative. So it gets the HSO4 negative. Obviously, it will be very near to the positive charge with a negative charge here, HSO4 negative. So it gets, first of all, a salt. But when you heat it up, when you heat it around 453 to 73 kelvins, then in that case, what happens? Water gets removed from here, and you get the benzene ring like this, NH2 and SO3H. Okay, you get the SO3H. Now here, this is known as sulfonilic acid. Sulfonilic acid. This hydrogen of sulfonilic acid is still acidic, and that is why this is present in a equilibrium of some sort with this hydrogen getting abstracted by the NH2 group. So you have NH3 positive here, and here you have SO3 negative. Now, this type of compounds which have positive and negative, both the charges in the same molecule, positive and negative charge in the same molecule, we call these type of things Zwitter ion. We call this Zwitter ion. And then you will write a note. Please write aniline does not show. Aniline does not show. Friedel-Crafts reaction. Due to the formation of salt with AlCl3. In Friedel-Crafts acylation and Friedel-Crafts alkylation, we use AlCl3, which is the catalyst. Okay, the Lewis acid, AlCl3, the Lewis acid used as catalyst. Due to this, the NH2 becomes acidic again. The nitrogen gets a positive charge. The nitrogen of aniline gets a positive charge and acts as strong deactivating group. Therefore, it does not show Friedel-Crafts reaction. फहद CHCl3 और AlCl3 के प्रेजेंस में तो कुछ नहीं मिलेगा आपको. प्लस एक और चीज होना चाहिए ना, और क्या होगा? What will be the other reactant here, फहद? ये तो रिएजेंट हो गया ना, एक और होगा ना, क्या होगा? टॉलुइन के लिए क्या चाहिए और? बेंजीन. हाँ, बेंजीन में रहेगा तब जाके, बस सही. यही AlCl3 ना, so that is why that these reactions are known as Friedel-Crafts alkylation, and we have to use AlCl3 because what happens? This chlorine, it attacks on this aluminium, because aluminium is what it is having only 3 bonds. 3 bonds means it is electron deficient. That is why chlorine with its lone pair electron, it attacks on the aluminium and making CH3 positive. Then this CH3 positive is attacked by the ortho and para position of the benzene rings. If it is substituted benzene, अगर benzene है तो फिर सिर्फ किसी एक कार्बन से अटैक कर देगा बस. That's it. But in this case, what happens when we have aniline? So nitrogen के पास भी lone pair electron है, and nitrogen attacks on the AlCl3. And when nitrogen attacks on the AlCl3, then what we have? We have got nitrogen with a positive charge, and nitrogen with a positive charge will be highly deactivating, and that is why it will not show any further reaction. Okay, so please write this down. After this, we'll write the topic Diazonium salts. First of all, diazonium salt, they have a general formula. They can be alkyl diazonium salt, Rn2 positive, Cl negative, or they can be aryl diazonium salts, which benzene ring, N2 positive and Cl negative. No, not Cl negative, rather. I should say right now it is X negative. Now this X can be some different groups. Okay. So these are the two types of diazonium salt that we can have, and in which X negative can be mostly it is Cl negative, then we use Br negative, but it can also be HSO4 negative. It can also be BF4 negative, etc. Okay, and here the R is alkyne and AR is the aryl group. Now, we have seen when we get alkyl diazonium chloride, then it is very reactive and it is unstable. It even reacts with moisture to give alcohol. So please write first of all, alkyl diazonium salt is very unstable. Okay. And reacts even with moisture. Moisture मतलब water, ठीक है ना, जो आपकी एयर में वाटर होता है ना, बस वही moisture to give alcohol. What about aryl diazonium salt? So these are stable because of resonance. Aryl diazonium salt are stable due to resonance. So here we have double bond, single bond, double bond. Then we have R, this nitrogen with triple bond nitrogen and a positive charge. Okay. Now, first of all, what happens? This pi bond moves here. It gives the electron to nitrogen. Now, nitrogen cannot have 5 bonds, so it breaks one of the pi bond with this nitrogen, and we get the first resonating structure in which you have double bond nitrogen, and this is also having a double bond with another nitrogen. This nitrogen still has 4 bonds, so it will be positive. Okay. Now this nitrogen, it gets a negative charge here because it has got electrons. These pi bonds are as it is, and we get a positive charge on this particular carbon atom. Now, the electron movement follows simple rules of resonance. Pi bond goes towards the positive charge. These things are as it is, double bond N, negative, positive. And then we have this bond as it is, and we get this new bond with a positive charge on the para position. And then this electron moves here. We get one more resonating structure. Double bond N, positive on this nitrogen, negative on this nitrogen, a double bond here, a double bond here as it is, and we get a positive charge here. Now, what happens? This pi electron moves here. As soon as this pi electron moves, this negative charge also forms a bond with this nitrogen atom. And you get the last resonating structure. That is double, single, double, single, double, and single bond nitrogen, triple bond with this nitrogen, and this still has a positive charge. Okay, so all of these are resonating structure. All of these resonating structure, these have net positive charge, net one positive charge. If you look at the first structure, it has one positive. Second structure has 2 positive and 1 negative. That is why it is what? That is why it is going to be net positive. Okay. But it has 5 resonating structures. That is why it is stable. Now, coming to the methods of preparation. Method of preparation is only one that we have already seen. Is right. MOP. The reaction is known as diazotization of amines. Diazotization of amines. Okay. Now in diazotization of amines, what do? We get the benzene diazonium salt by reacting benzene with NH2 group, that is aniline, plus we have NaNO2, plus we have HCl at low temperature, that is 0 to 5 degrees Celsius, and we get the benzene diazonium chloride. N2 plus Cl negative, we get sodium chloride and water also, but this is my main molecule that we need to remember. This is benzene diazonium chloride. We also call this benzene diazonium chloride, BDZ. Right, next, chemical reactions. Benzene diazonium chloride. So the first chemical reaction is Sandmeyer reaction. Now, in Sandmeyer reaction, we have the benzene diazonium chloride, N2 positive and Cl negative. Let's scroll up. अच्छा लिख लीजिए आप इसको ऊपर. Try to write on your own now. आपको देखने की जरूरत नहीं है. ये रिएक्शन तो पहले भी कराया ना. I have done this reaction today only, right? So try to write on your own now. When you hear this diazotization, when you see the reactants, then you should be able to write the reactions completely. Okay. Okay. Now please listen for Sandmeyer reaction. In Sandmeyer reaction, we use cuprous chloride, cuprous bromide, or cuprous cyanide. Okay. So there are three reactions which can be known as Sandmeyer reaction. Now, if you use Cu2Cl2 or CuCl, cuprous chloride, in the presence of HCl, you get a chlorobenzene. Benzene ring, and the diazonium group is replaced by chlorine. If you use cuprous bromide in the presence of HBr, you will get bromobenzene. And if you use cuprous cyanide, that is CuCN, in the presence of KCN, the diazonium group, N2 group, will be replaced by CN. We'll get benzene nitride. Similar products are given by another reaction that is known as Gattermann reaction. Okay, please remember Gattermann reaction and the Gattermann-Koch reaction, it is different. Okay, Gattermann-Koch reaction is different. This is just Gattermann reaction. Now in Gattermann reaction, you have the benzene diazonium chloride. If you have only copper in the presence of HCl, you'll get the same chlorobenzene. If you have only copper in the presence of HBr, then you will get bromobenzene. But these reactions are what? These reactions are Gattermann reaction. Although we are getting same products, but the yield is better. But the yield is better when you have Sandmeyer reaction. Okay, so Sandmeyer reaction is more effective. Please write this down, complete this thing. After Gatterman reaction, please write C. Other substitution of Diazonium group. Okay. Now you write these reactions on other substitutions. When I use Ki, then diazonium is replaced by iodine. When you use HBF4, then it will be replaced by BF4 negative. Cl will be replaced by BF4 negative, and further heating gives you fluorobenzene. ठीक है, so iodobenzene, fluorobenzene, chlorobenzene, and bromobenzene सारे के सारे हो गए diazonium salt से. ठीक है, so please remember that. If you have, अगर आपके पास NH2 है, aniline है, so from here you can also make chlorobenzene, bromobenzene, iodobenzene and fluorobenzene. ठीक है, सब बन सकता है. All through what? All through the benzene diazonium chloride. All through BDC. अगर आपके पास aniline है तो BDC कराइए NaNO2HCl and उसके बाद Sandmeyer reaction, and this you will just heat it with Ki, and for this you will first of all use HBF4 negative and then you will heat it, so you will get fluorobenzene. ठीक है. Now again, if you want to remove this benzene diazonium, this diazonium group here, then you can react this with H2O plus H3PO2 or just ethanol. So even if you have, for example, NH2, और आपको NH2 यहाँ से हटा देना, so first of all you will convert this to BDC, and then you will react this with ethanol or H3 plus H2O plus H3PO2. ठीक है. And then you have what? And then you have just reaction with water. It will give you alcohol जैसे देता है उसी तरह phenol दे देगा. And if you have HBF4 and then further you react with NaNO2 in the presence of copper and heat, you will get nitro group. Okay, so please write this down. Right, the last reaction, coupling reaction. Let me know once you have written all of these reactions.
Done, sir.
Now, coupling reaction of diazonium chloride, it is done with phenol and also aniline, and it gives colored products. Okay, and these colored products are also used in dyes. That is why it is important. So if you have benzene diazonium chloride, N2 plus के साथ यहाँ पे Cl negative भी होगा. Okay, plus we have phenol. Okay, so what is going to happen from here? This HCl is going to get away. Okay, and then what you are going to get? This benzene ring, nitrogen with double bond nitrogen, and this nitrogen has a single bond with the carbon which was having hydrogen, and you have OH here. Okay, this is done in the presence of in acidic condition, and it is an orange colored dye. This is orange in color. If we have the same reaction but with aniline, nitrogen में ऐसे triple bond होता है, right? You have positive charge here and we have Cl negative here. Similar reaction with aniline. This is done in basic condition. Okay, it is done in basic condition. Phenol acidic होता है तो acidic condition ताकि वो किसी और से react ना करे. And aniline is basic, so it is we use this in basic condition, and we get nitrogen with a double bond nitrogen here, single bond OH, and here we have yellow colored dye. Please write this down. Then honestly, yes or no?
Done.
Yeah. Now please see, since all of these 4 chapters are done, अब आप लोग you need to prepare and you need to concise this complete thing in 10 to not 10, 12, 13 pages. Okay. What you need to do is you need to have, first of all, method of preparation of haloalkane halorine. I think you have this already. Then you will prepare method of preparation, 1 page. Okay, single page, method of preparation of haloalkane halorine, method of preparation of alcohol, phenol, and ether. Third is method of preparation of aldehyde and ketone. Since you have a lot of reactions in aldehyde and ketone, you will make another for carboxylic acid. Okay, and then 5th is the method of preparation of amines. So this will be your 5 pages. Okay, and whenever you are writing method of preparation and in which you have, for example, let us suppose you have a name reaction. So how you note that down, that this is a name reaction. And for example, if you have a chemical test, for example, method of preparation of haloalkane halorine, you will see Lucas reagent. Same thing you will see in the method of preparation method. Chemical properties of alcohol phenol, you will see Lucas test. Okay, so वहां पे भी आप वहां पे थोड़ा सा denote कर दीजिए that this is a test. Okay, and then you will have 5 method of preparation pages, and then you will have 5 pages for chemical reactions. ठीक है, और भी चीजें आपका कुछ चीजें जो हैं आपके पास, जैसे फॉर एग्जांपल इफ यू हैव एडिशन on alkene, then what rule do we have? We have Markovnikov rule and we have anti-Markovnikov rule. And when we are doing elimination, we have Setzeff rule. Okay, तो इन सारी चीजों को आप वहां पे डिनोट कर दीजिए. फॉर एग्जांपल अगर हम HBr यूज कर रहे हैं in the presence of sunlight, है ना, then it is going to be anti-Markovnikov rule, right? If you are having just HBr, nothing is present there, then it is going to be Markovnikov rule. So those things you will represent. So this will give you what, 10 pages. ठीक है, after you are done with this, ठीक है, after you are done with this, you will take a sheet, okay, a single sheet, A4 size. आप चाहे तो दोनों यूज कर लीजिए, लेकिन you will take a A4 sheet paper and then you will make a line in between like this, and then chapter 1, haloalkane halorine, first name reaction, second name reaction, only the name of the name reaction, पूरा reaction मत लिखिएगा आप, ठीक है. नेम रिएक्शन, नेम रिएक्शन, नेम रिएक्शन, नेम रिएक्शन, जितने भी हैलोल्केन हैलोरीन में नेम रिएक्शन वो आपने लिख दिया। अब उसके बाद अब नेम रिएक्शन लिखा और आपने साथ में यहाँ पे लिख दिया एम। एम का मतलब दैट इज प्रेजेंट इन मेथड ऑफ प्रिपरेशन। ठीक है, मान लीजिए कोई आपके केमिकल रिएक्शंस में, तो यू विल राइट सी, केमिकल रिएक्शन जाके देखना है दिस नेम रिएक्शन। यू विल जस्ट राइट दिस नेम डाउन बिकॉज एट द एंड जब आप लोग के केमिस्ट्री एग्जाम से कुछ दिन पहले होगा, ये सारे नेम रिएक्शन आप सिर्फ नाम पढ़िएगा and then you will recite all the reagents, all the substrate and all the products, whatever is there. So please don't write the complete reaction, आपको लिखना ही नहीं है, सिर्फ नाम लिख दीजिए। For example, Sandmeyer reaction, for example, Swartz reaction, Finkelstein reaction, okay, Friedel-Crafts alkylation, Friedel-Crafts acylation, ठीक है। So all write all the names, चाहे वो Friedel-Crafts alkylation, acylation सारे चैप्टर्स में आ रहा है, फिर भी सबके बारे में लिखिए आप, ठीक है। You just write all the name reaction of halorine. Secondly, you write all the name reactions of alcohol, phenols, ethers, and so on. You will write the same thing for aldehyde, ketones, and amines also. So you'll get this one sheet that is completely of what? It will have all the name reaction with respect to the chapter. ऐसे उल्टा सीधा मत लिखिएगा प्लीज, ठीक है ना। Chapter wise you remember the name reactions, okay? You will remember the name reaction chapter wise. Then what you are going to do? You are going to make again a sheet of paper. ठीक है, you will make again a sheet of paper, and then here you are going to write all the Y type of questions. ठीक है, कि पैरा डाइक्लोरोबेंजीन का मेल्टिंग पॉइंट क्यों ज्यादा होता है ऑर्थो एंड मेटा आइसोमर से, कार्बोक्सिलिक एसिड व्हाई इट इज मोर एसिडिक देन, ओनली क्वेश्चंस, आंसर्स भी। आंसर्स आपको याद होने चाहिए, आपके लास्ट में टेस्ट करने के लिए आप खुद को, ठीक है, कि आपको ये सारी चीजें आती कि नहीं। ये आज सारे नेम रिएक्शन आपके दिमाग में होने चाहिए और ये सारे वाई टाइप ऑफ क्वेश्चंस आपके दिमाग में होने चाहिए, ठीक है। सो यू मेक दीज 2 sheets of paper. Now one more sheet of paper that you need to make, and that will be a small sheet of paper. You don't need to have big sheet of paper. आई थिंक मतलब वो शायद आपको इस तरह से पार्टीशन भी नहीं करना पड़े पेज में, इधर और इधर लिखेंगे हम। यू जस्ट नीड टू राइट हैलोल्केन हैलोरीन, व्हाट आर द टेस्ट्स, इसमें कौन कौन से टेस्ट हैं, सिर्फ टेस्ट का नाम लिखिएगा। क्या डिस्टिंग्विश करता नहीं डिस्टिंग्विश करता वो आपके दिमाग में होना चाहिए, बट यू शुड नो ऑल ऑफ द टेस्ट, हैलोल्केन हैलोरीन में, अल्कोहल फेनॉल्स ईथर में, एल्डिहाइड कीटोन्स कार्बोक्सिलिक एसिड में, ठीक है। तो ये 3 पेजेस जो है ऑफ ऑल द नेम रिएक्शंस, देन ऑल द वाई टाइप ऑफ क्वेश्चंस, ठीक है, एंड ऑल द टेस्ट्स, सिर्फ नाम चाहिए, ठीक है। यू आर गोइंग टू गिव मी दिस नेक्स्ट ईयर, ठीक है, जब आपका सारा सिलेबस कंप्लीट हो जाएगा तो उसके बाद आपके पास ये तीनों हमको चाहिए, ठीक है। ऑल द नेम रिएक्शन, ऑल द वाई टाइप ऑफ क्वेश्चंस एंड ऑल द केमिकल टेस्ट्स दैट वी हैव। टेस्ट के बारे में डिटेल्स आपको नहीं लिखने, टेस्ट आप यहाँ पे फिर से वही कीजिए। टेस्ट में आपने जो टेस्ट लिखा वो आप मेथड ऑफ प्रिपरेशन में है या फिर केमिकल प्रॉपर्टीज में, आप बस ये लिख दीजिए मेथड ऑफ प्रिपरेशन या फिर केमिकल प्रॉपर्टीज, कहाँ पे देखना है आपको, किस पेज में देखना है इस टेस्ट के लिए। और केमिकल प्रॉपर्टीज में अगर है तो उस रिएक्शन